It's kind of funny, this has got a higher number, but this one's a lot easier than the one we just did. They give me the function of velocity. K and C are constants, and I want to figure out the length that gives the minimum velocity. So this is, I didn't have to construct the equation myself. That's the worst part of these equations, is when you have to construct it yourself. That's the hardest part. So all I have to do here is what? What's the only thing I have to really do here? All right. You guys aren't going to help me out. So the thing to realize, K and C are both constants. So when I take, of course I'm going to take a derivative so I can figure out the minimum. Right? If I want to figure out minimum velocity, I needed a velocity function. They gave it to me, thank God. I don't have to create it like we did with the area function. Then I just take its derivative and start looking for critical numbers. So let me write this a little bit better. Let's see. 1 over c times L plus c times L to the negative 1 to the 1/2. L is the variable here, right? That's the length of the wave. So now I just attack it with derivatives. Its derivative would be K times 1/2. And then the derivative of the inside, you can see why I wrote this way. It'll just be 1 over c plus, and in this case it'll be minus, right? That's the derivative of the inside. Set that sucker equal to 0, yes?
I'm just wondering why you chose to rewrite it that way originally.
I guess the part...
My inclination might have been to do a common denominator. Would that not have been appropriate?
It would have been fine, but then you would have forced yourself to use a quotient rule, and I kind of told you I have kind of a built-in aversion to that. But if you don't have that same aversion, yeah, you could totally make that one big-ass fraction inside. Yeah. Totally. So now, you want to find the critical numbers of this. And just to make this look a little bit better, what do I have on top? I sort of have this over 2 times this yeah, okay. Considering that L is positive, that's the length of a wave. So where do critical numbers come from, in general? Where do critical numbers come from? Where it's 0. So that would involve what? How would I figure out where this derivative is 0? What would I look at? What's the only way a fraction could be 0 is if the top is 0. So one place I'm going to get critical numbers from is K over C minus KC over L squared equals 0. And the other place, of course, would be where it's undefined, which is where this would be 0. Right? And when is that 0? When L over C equals negative C over L, when L squared equals negative C squared. And that can't happen. Is that cool? So there's no critical numbers related to undefined in this problem. So, and then that is a very simple little dude to solve for L, right? If I add that over, multiply by L squared, divide by K, multiply by C, L equals C. So whatever that C constant is, it seems to be the length of the wave that makes the velocity minimum. Possibly. I still have to check to see if that really would be a minimum. All right, so 57 wasn't too bad. $58. Let's see. All right, let's start 58 on. Let's do 59, then we'll come back to 58, and we'll see what you guys think. Let's do 59. 59 is a problem that is a standard problem in like Math 178, which is the business calculus, basically. It's science calculus, really, where they do a lot less theory calculus. Because this is the kind of problem you'd want to do in business. How do I maximize profit? What do I set the ticket price at? So, hockey team, seating capacity is 15,000 people, with the ticket price at $12. The price is $12. The attendance has been 11,000. Each dollar the ticket price is lowered, the attendance will go up by 1,000. Tell me right now, how much money are they making on average with the ticket price set at $12? Can you just tell me that? How much money are they making on average with the ticket price at $12? Yeah, you just take 12 times 11,000. All right, $12 per ticket times 11,000 tickets, $132,000. That's pretty damn good. But they want to see, can I squeeze some more out of that? Can I change the ticket price so that I get more money in the end? Every dollar the ticket price is lowered. So what is it I don't know in this problem? So for every dollar the ticket price is lowered, average attendance increases by 1,000. So if I put this at 11, if I do 12 minus 1, what will the attendance become? 12,000, 11, right? It'll be 11,000 plus 1,000. If I do 12 minus $2, the attendance will be 11,000 plus 2,000. So what is the thing I don't know? I know I don't know the ticket price I want at the end, but what is it really that I'm changing? I'm changing how much this is. So for 12 minus X, what will the attendance do? 11,000 plus 1,000X. So every dollar this goes down, this goes up by 1,000. So what's the profit based on X? It's going to be the same thing we did over here. It's going to be the ticket price times how many tickets I'll sell. And now I've lost interest. This is like a pre-calc problem, really, because you're going to get a quadratic. The best situation is going to be at the vertex. But we don't have to do all that. We could do calculus stuff, right? So you could FOIL this out, or you could just use product rule based on this. I've got my profit function. In fact, I guess it's revenue. I got my revenue function. In order to maximize that, I'm going to take its derivative. Set it equal to 0, same old thing. So what changes in these problems? How I get to the equation. What's the same in every one of these problems? Then I set it equal to 0, or look where it's undefined, get critical numbers, go from there. Why do I know that the answer I'm going to get is going to be a maximum situation? What kind of equation is this going to be? What does this look like if I graphed it? Nope. Negative x squared. So it's going to be a down price. So I'm going to have a maximum revenue up there. I like it. So then you can distribute. There's the 132,000 minus 11,000 plus 12,000, so I get plus 1,000x. So minus 11,000x plus 12,000x, and then minus 1,000x squared. I take a derivative, and it looks like x is going to be 1/2. Is that cool? So if I lower the ticket price by $0.50, that looks to be the sweet spot in terms of revenue. It's kind of nice, because what did x represent? The number of dollars I'm going to lower that ticket price. I get 1/2, so I'm going to lower it down to $11.50. That looks to be a sweet spot. Now, there are people that are called financial analysts. A friend of mine does this work. He has 5 kids, so thankfully he's a financial analyst and makes, 6 figures, so we can afford all that stuff. But this is kind of like a very simplified version of the work they do. They're constantly analyzing the forces in the out there in the environment that are affecting where things should be set, trying to predict what the sweet spots are, that kind of thing. That's a part of what they do. Oh, let me give you this before I forget. Let me go ahead and give you guys this, and then we'll look at number 58. I think it was 58, yeah. So let's at least look at the beginning of 58. It's really not as bad as the circle and a triangle problem, the almost Deathly Hallows looking thing. But it still gets kind of a lot of parts to keep track of. So you got a right circular cylinder. Are you working? No? And it's to be surmounted, excuse me, by a hemisphere. Okay. What dimensions require the least amount of metal? So I'm going to put on top of this a hemisphere. I'm going to make a little trash can. And they tell me the volume is V. Thanks. Problem. They tell me the volume is V. So what are the important dimensions up here? What are the dimensions? What are the dimensions they talk about? What do we need to know about the cylinder? Height. I like it. There we go. Height. And of course the radius, which relates to the hemisphere as well. All right, pretend like that's a hemisphere. So what does that mean, the least amount of metal? What geometric aspect of this does that relate to? Surface area. I like it. What's the volume of this? I don't know if you guys remember. And if I give you a problem, I will give you the formula, but I wish I didn't have to. There's a circle at the bottom, right? What's the area of that circle? Area of that circle. Pi r squared. And how many circles are there? H. Okay, there's the volume of a cylinder. But then I have to add a hemisphere. What's the volume of a sphere? Sphere. Hemisphere. Anybody remember? I like it. Cool. And again, I would give that to you. So that's the volume. This is what they tell me. They tell me this. And what do they ask me about? They ask me, like you said, they ask me to minimize the surface area. Okay, this is really, really, really cool. And it's a bad feeling you guys don't trust me when I say that, but pretend like this is the cylinder is a soup can, and if I take the label off, doesn't it make a rectangle? So the surface area of a cylinder is just the area of that freaking rectangle. So how tall would that rectangle be? It would be h. How wide would that rectangle be? So if you chop this and open it, what is this coming from? If I open that sucker, so if I have a cylinder, right, there's the soup can label, and I chop it and open it, what is this? That was the, no, what is it? Circumference of the circle. Yeah. And what's the circumference of the circle? 2 pi r. So what's the surface area of the cylinder? Surface area of the cylinder is going to be 2 pi r h plus this one side. This other side just got the, I don't know, did they say? We're going to have to assume that this wouldn't make any sense for this to actually have metal here. Why would they put the lid on that sucker? So it's going to be plus the bottom, which is, of course, pi r squared. And what's the surface area of the sphere? I don't know if you guys remember the surface area formula of a sphere. So it's a hemisphere. So hemisphere. It's really just the derivative of this guy, which is kind of nifty. So the surface area of the whole shape is going to be 2 pi r h plus 3 pi r squared. Oh shit. And here's what they tell me. They told me that the volume is pi r squared h plus 2/3 pi r cubed. Which, so do you remember how to work generally these problems where they tell me something and they ask me something? What do I want to do with this? How many variables are in there? 2. H and R. That's one too many. So what do I want to do with this? I know it looks more disgusting than we're used to, but I don't care. What do I do with this to help me with this? Solve for, in this case, I'm going to definitely solve for freaking H, right? Solving for R would not be easy. Okay, so again, any example we do, what you're trying to get from it are the steps that are being taken and why they're being taken. This specific problem, I am never going to give this to you. I already did. I would never give this problem to you again. Will I give a problem to you that uses the same idea? Hell yeah, shit, that's the whole point. So they tell me something, it's gross looking, I don't care. They tell me something. They ask me something, kind of gross also, I don't care. I want to take what they tell me and solve for something that will help with what they ask me. That's what we always do with that. So when you solve this for h, you get that weirdness. Right? V minus this divided by pi r squared. Is that pretty? No, I don't care. Right? You just got to keep track of it. And then I can take, what can I do with that? I'll tell you what to do with that, Jeff. I can take this, throw it in there, and then I have a surface area that's dependent on R only. And I could do something with that. Say again? No, the V is a constant. They told me, yeah. So it is a constant. They just didn't tell me what the number is, but yeah. So now I'm going to get S equals 2 pi r times all that business. So that's 2 pi r times h plus 3 pi r squared. And again, if any of your brain kind of shuts off because there's a lot of parts to that, stop it. There's a lot. Oh well, that really means it just takes longer to write than other problems. It doesn't change what I'm going to do. So what can I immediately do to make this better to look at? Kill the pi. Sounds terrible, but oh well. Kill 1r. That's better. So let's see if I can write this better. So let me write this kind of broken up. So I get 2v over r minus 4/3 pi r cubed over r. So that'll be pi r squared. You guys with me? Plus 3 pi r squared. All right, that's neat. I got all kinds of like terms. So I get 2v over r. What'll that be, Jeff? Can you do it? I don't know, man. Is it plus 5/3? Sounds about right. All right, those are like terms. And then what do I... So all that work was just to get to the function that I want to attack. So now how do I attack this function? Yes. All right, 2 times 2/3. And then 1r cubed died. Right? Is that cool? So now what do I want to do? I've got, what is it asking me to do? Minimize the surface area. I have created a surface area function, so now what do I do? Yeah, find it. How do I minimize blank? Get an equation for blank, take the derivative of blank, find the critical numbers. That process doesn't give a shit that there was a lot of weird parts to it. It doesn't care. It says make the function and then attack it with a derivative. So remember what I said here, something over r, the derivative is going to be negative that over r squared. And then this is going to be nice. And then where's this undefined for r equal to 0, which would make no sense. Right? So I can ignore that critical number. Now I just got to set it equal to 0. Here, I'm tired. You guys finish that up. Solve that. I guess we are doing the whole thing. Yeah, this is not quite as disgusting as, like I said, the circle in the triangle. Well, let's do this first. Yeah, okay. So what you guys are getting? So you multiply the r squared up, you get r cubed. You divide the pi down, you divide the 10 down, multiply the 3 up. Yes? So then r is the cube root of that. Definitely not an intuitive answer, but that's why calculus exists. So if I make the radius of this thing this, and I know we're not done because there's one more dimension to figure out. If I make the radius this, that's going to result in a cylinder in this shape with the least amount of metal. And if I'm going to make like 8 billion of these, and I can minimize the amount of metal each one needs, and I have the same volume, I'm going to minimize my overall cost. Right? I'm also going to be conserving metal. That's nice. So what's H going to be? H is all this business. So now I can throw on. This looks exciting. I take that and I put it in here to figure out what H is. And ask me to put all that shit in. Any specific problem, the actual specific parts of that problem do not matter. Now, I'm still going to take points off of you to get the wrong answer for a specific situation, but in terms of learning what to even do with the problem, what are the important parts? They told me something, they asked me something, I write the equations for both, and then I use what they tell me in what they ask me. So now I've constructed a surface area formula. I can attack it, figure out the minimum surface area. So I try to focus on those tell me, ask me type problems. That is so ubiquitous. I love that word. It's everywhere, and it's in the real world. That's exactly how the real world works. Stuff I know and stuff I don't know. Okay, so we got those done. I'm going to open it back up to anything you guys want to look at, talk about. Still going? Yeah. I'm just looking at stuff. Section 4.7 stuff. All right. just want to remind you guys about something. I've discussed this before, I'm pretty sure, but I assign homework problems to do. And I think didn't I tell you that as a student, I never got the homework completely done. I'm pretty sure I told you that. I was working 3 frickin' jobs, so I did what I could. Teacher was like, why don't you ever finish this? I'm like, dude, real life, I don't know what you want from me. Okay, but I did enough so that I could do the test well, right? So if you are in a crunch in terms of homework, let go of getting every single one done. Homework is not worth enough to kill you by itself. What will kill you is not doing well on the test. So what do you do then? You start doing the odd ones, because the answer's in the back. If you have the solutions manual that comes with the book, it's a really good idea, because then it shows you all the steps too. Not a place to copy from, but a great place to double check what the hell you're doing, right? And then if you want more practice, you go to the review and do some of those, because those answers are in the back of the book, right? I mean, this is part of what making education your own means. Well, I yell at you about not finishing homework. Yeah, I'm going to correct this. What the hell? And you're going to go, I'm doing what I can. I'm taking control of my own education. I'm doing what I need to do to get ready for a test. And I don't know if you guys, I've never wanted to kind of force this to happen, but the only way I survived a lot of my upper level math courses was to have study groups. My God. Because you get everybody has a little bit different ability with everything, so we sort of fill each other in a bit. So I know right now there's only a few of us surviving so far, but you should try to group up. You should try to meet. And sometimes, in the past, I used to go out and meet groups of people at Starbucks or something. Right? I mean, I don't know if you think you're completely on your own. It doesn't make sense to me. I'm here. I'm in my office. I'm working with people. I set up some outside appointments with people. The tutors, are they helping? Are you going to see the tutors? Yes? Okay. Oh. Any other general or specific questions from anything? Yes.
Do you want to do a quick mean value?
Okay. Yeah, because I can't. What was the? There we go. So what are the requirements for the mean value theorem to hold? Because I am going to ask you to verify those hold, just like in the homework, just like on the practice test. What has this got to be true? In fact, you see this in a lot of theorems. One very basic thing that normally has to hold for a function in almost every theorem is that function has to be continuous. I like it. As if it can do weird shit like that, then it's really easy to break whatever rule I'm trying to set up. So for the mean value theorem, f of x has to be continuous on a, b, and it also has to be differentiable on the closed interval, open interval. And this is so desperately beautiful of a theorem. Because what's the very first thing we learn in calculus, and then we use the shit out of it, is derivative. And we know derivative is slope. And that's really what this theorem is throwing in your face, is the fact that the derivative at some point has to equal the slope around that point. Right? And I think on the answer key I reverted, I didn't even use C in there because I always used to just use X. It's just a dummy letter anyway, it doesn't really matter. But, so for this example, you want to do the one on here, you want to do a different one, or? Well, there's two of them on here, so we might as well look at this. So like, look at part B. So is this continue, and it's on the interval, this is really important. Where'd it go? -3 to 0. Got it. Where's the only place where this guy has a problem? This guy has a problem at Bloomingdale's. No, he has a problem at 1. That's the only place this is undefined. And is 1 in here? No. So by definition, every rational expression is differentiable and continuous on its domain. So therefore, these two, f of x is continuous on -3, 0 because only discontinuous at x equal to 1. And it's differentiable by definition. Right, there's a theorem that states rational functions are differentiable on their continuous and differentiable on their domain. So then, really, this is so nice. Look at this side. How would I do this side? What's b? 0. So this would be f of 0 minus f of -3 over 0 minus -3. And this side requires me, what's f prime going to be? I got to use a little quotient rule stuff on there. So just to cut the chase, I think it comes out to be this, if I remember correctly. Yeah. Okay. So then what do I put here? I put f prime evaluated at c. You don't have to use c if you don't want to, because I didn't. Right? So this way of looking at the slope must equal this way of looking at the slope. It's kind of beautiful. So I get -2 over c minus 1 squared. F of 0 is 0. F of -3 is -6 over -4 is -3 halves over 0 plus 3. 3 halves divided by 3 is 1 half. Right? I mean, now, the rest of this is algebra. Where's that? Oh, minus. Remember the minus? Yeah. Oh, -6. Yeah, that's right. That should be minus. Bam. So then I end up with 4 equals c minus 1 squared. I mean, right? Are you guys with me? Once you get this set up, dear God, the rest of this has to be easy. This is just an equation. Is everybody cool? Any steps of this that doesn't make sense? So at the heart of mean value theorem is one way of looking at derivative and the other way of looking at derivative. And it's saying that for nice functions, those two things have to be equal somewhere. That really makes a ton of sense. And now here I can take a square root. C minus 1 equals plus or minus 2. So I get C equals 3, or what is it, 1? -1. And which one of those is actually in the interval? -1. Yes? This one? Oh. So So what I got here is negative 2 over c minus 1 squared equals negative 1/2, right?
Yeah.
Multiply by negative 2. And then multiply this up. And that's how I get there. Good old cross multiplication. Yes?
So we have to test this.
Yes. So it's 3, 7, 3, 10, 3, 11, and then what was it? Chapter 4 up to 4, 7. We stopped at 4, 7. So we'll finish chapter 4, after this test. Not the same day. Now, if you'll notice real quick, my office hours unfortunately on Mondays I have a meeting from like 9:30 to 11. But again, you could always just email me a few options about when you're available. I'm in my office more often than that. Seems like nobody wants to come out any earlier than 7, because I am in my office normally starting at like 5:30 or something insane. You can always just knock on the door if it's locked, or walk on in if it's open, or say, no, Jeff, I have enough trouble getting up to 8 or 7. Up to you.